Hello students, today we will continue analytic function. If f of z is analytic, show that da by 2 upon da by x square plus da by 2 upon da by y square operated on f of z modulus square is equal to 4 modulus f dash z square. Now, let f of z is u plus iv. Then modulus of f of z will be under root u square plus v square. So modulus f of z square will be u square plus v square. Now derivative dabba upon dabba x of mod f z square will be dabba upon dabba x of u square plus v square. Now if we partially differentiate u square plus v square with respect to x, then we get 2u ux plus 2v vx, where ux is dabba u by dabba x and vx is dabba v by dabba x. Now second order derivative of mod f of z square with respect to x is equal to dabba upon dabba x of this first order derivative. Now, if we use here product rule of derivative for ux and vvx, then we can write two constant as it is uxx plus ux into ux, that is first into derivative of second plus second into derivative of first for this term. Similarly, we can write 2vvx for that 2 into bracket first into derivative of second plus second into derivative of first. Now, we can write this as 2uxx plus 2ux square plus 2vvxx plus 2vx square. Similarly, we can write second order derivative of mod f of z square with respect to y like 2u plus 2uy square plus 2vvyy plus 2vy square. Now, we can write addition of these two derivatives dabba 2 upon dabba x square plus dabba 2 upon dabba y square mod f of z square is equal to addition of these two. But since f of z is analytic function, u and v satisfy Laplace equation, and from this we can say uxx plus uyy equal to 0 and vxx plus vyy equal to 0. So these two terms will become 0 since the function satisfies Laplace equation. So these two will be 0 directly. Now we can say again f dash z is nothing but ux plus ivx. But by Cauchy-Riemann equation, ux is vy and uy is minus vx. So this is how we can write by using CR equations. Now modulus of f dash z mod f dash z square can be written as ux square plus vx square. That is nothing but vy square plus uy square. Therefore, if we use these two, then ux square plus vx square, for that we can write f dash z modulus square, and uy square plus vy square we can write again as mod f dash z square. So now dabba 2 upon dabba x square plus dabba 2 upon dabba y square operated on modulus f of z square will become 2 times 2f dash z square, that is 4 modulus f dash z square. So here we have considered left hand side of the problem, then we have used product rule of derivative, then we have used that function is analytic, therefore uv satisfy Laplace equation, and we have used again that f dash z is ux plus ivx and CR equation. So these many things we have used to solve this problem. Now consider next example. If f of z is analytic function of z and f of z is u plus iv, then prove that dabba square upon dabba x square plus dabba square upon dabba y square operated on modulus of real part of f of z square equal to 2 modulus f dash z square. Now consider left hand side. If we simplify this, then we can write dabba upon dabba x 2 times operated on u square and dabba upon dabba y 2 times operated on u square. Now derivative, partial derivative of u square with respect to x will be 2u ux, and here with respect to y, if we differentiate, then 2u uy. Now this is nothing but uh, again we have to use here product rule of derivative, that is first into derivative of second plus second into derivative of first. 2 2 is constant again, and here also product rule of derivative, differentiation with y. So these four terms we are getting. But now see, function is analytic, that means definitely u and v means real and imaginary part of the function will be harmonic functions. We have studied the remark that function is analytic, then u and v will be harmonic. So if we use this remark, then since u is harmonic, we can say dabba 2u upon dabba x square plus dabba 2u upon dabba y square is 0. Now left hand side is equal to 2 times dabba u upon dabba x square plus dabba u upon dabba y square, because these two terms, from these two terms if we take 2u common, then we have just written that this addition will be 0. So these two terms will be, addition of these two terms will be 0. So only these two terms will remain. Now again, if we use CR equations here, then we know uy is minus vx. So in place of uy, if we replace by minus vx, then if we make squares, then 2 bracket dabba u by dabba x square plus bracket dabba v by dabba x square. So this is because of CR equations. Then this is nothing but 2 mod f dash z square. Just now in previous problem we have studied that f dash z, modulus of that will be under root ux square plus vx square. So if we make squares, then we can write in this way, these two are equal. This is the justification. F dash z dabba u by dabba x plus I dabba v by dabba x. So mod will be under root real part square plus imaginary part square. So modulus square becomes, we have to remove square root. So this is the justification for these two terms are equal. So this is what we have to prove. LHS, we have taken LHS, we have simplified LHS, and finally we are getting as 2 times mod f dash z square. Okay, so CR equations we have to use every time here. These CR equations are very important. So these are the things, all the things about analytic function. Thank you.